Welcome to this video on basic counting. We're going to talk about the fundamental counting principles and basic counting formulas that will form the building blocks of our enumerative combinatorics methods. Our first stop is the addition principle. Now, the addition principle expresses a pretty simple idea, and that's if I have two disjoint sets, A and B, and I want to know the size of their union, A union B, well, then I can just add up the sizes of those two sets. So we call this a principle because there's not really anything to prove here, it's more of an observation. Now in practice, here's how we're going to see the addition principle. Someone's going to ask us how many ways are there to choose a single element from the set A union B, and then the answer is going to be the size of A plus the size of B. We can generalize this idea and look at the union of multiple sets. And here the sets are pairwise disjoint, which means that they don't share any elements in common. In this case, we get the same sort of result. If I want to find the size of their union, I can just add up the sizes of the individual sets. So here's an example of this basic principle. Let's say I want to have a snack and I look in my refrigerator and I see that I have 9 different kinds of fruit and 10 different kinds of vegetables, and I want to know how many different ways can I pick something to eat. I take A1 to be the set of fruits and A2 to be the set of vegetables, and then I know that the size of A1 union A2 is just the sum of the sizes of the disjoint sets, and that is just 9 plus 10, or 19. And what I want to point out here is I'm actually performing a recipe when I pick my snack. And the recipe is as follows. I either choose a piece of fruit or I choose a vegetable. And when I count the number of ways that I can do this, the or corresponds to addition. This or is exactly this plus. I either pick a piece of fruit, I can do it 9 ways, or I pick a vegetable, which I can do in 10 ways. And so I have to add those two numbers together. That's really what the addition principle is. So now let's talk about the product principle. This formulation looks a little more complicated, but it's saying something pretty simple. What we're going to do is we're going to create a list of size 2. We're going to pick our first element from set A and our second element from set B, and we want to know how many different ways can I do that. The answer to that question is just the number of elements in A times the number of elements in B. We can generalize this. We can now have K sets, and now what I want to do is I want to pick an element from each of these K sets in order. And so what I end up with is this K tuple, right? So A1 comes from set 1, A2 comes from set 2, and so on. And the number of ways to create such an element is just the product of the sizes of the sets. And let's see how that looks in practice. So let's now say I've had my healthy snack and now I'm ready to go have an ice cream. And I go to my local ice cream shop and it has 6 flavors and 3 kinds of cones and 4 toppings. And what I want to know is how many ways can I order a single scoop cone with 1 topping. In this case, my set A1 are the ice cream flavors, my set A2 are the cone types, and my set A3 are the options for the toppings. And so the number of single scoop ice cream cones with 1 topping that I can order is the size of A1 times the size of A2 times the size of A3, which is 6 times 3 times 4, which is 72. And what I want to do again is point out the fact that I am actually following some sort of recipe when I'm creating my ice cream cone. And in this case, it's a 3-step recipe. First, I choose an ice cream flavor, and then I choose a cone, and then I choose a topping. So this is what the product principle looks like when we encounter it in a counting problem. So and then corresponds to a multiplication. So when we're following a recipe and we see the term or, that means we're going to do an addition principle. And if we encounter an and then in our recipe, then we're going to do a multiplication principle. And keeping those rules of thumb in mind as you're doing a more complicated counting problem can be really, really helpful because you have a clear methodology that you are trying to follow. Okay, so let's move on to our basic counting formulas. These are our 4 favorite formulas for counting sets and lists. And so let's go through them one by one. Let's start at the top. So the number of subsets of a set of size n. Well, that is just 2 to the n. And the reason for that is there are n elements that I have to decide about. And for each one, I have to decide yes or no, whether it's in the subset I'm going to pick. So maybe I say yes, no, yes, and so on, maybe yes at the end. Right? So I have 2 choices for each of those n elements. And so the answer is 2 to the n by the multiplication principle. So how about the number of subsets of n of size k? That is n choose k. And I'm going to give you a formula for that in a second, but I'm just going to write down that symbol for now. And that symbol means the number of k sets chosen from a set of size n. Let's move on down to the permutations. We've got a nice notation for that. It's n exclamation point, so that's n factorial. And here by the multiplication principle, I'm going to think about making a list of all of the elements in this set. I have n choices for what to place in the first spot, and then I have n minus 1 choices for what to place in the second spot, n minus 2, and so on, down to 3 times 2 times 1. Now, what if I want to make a list of size k? Well, it's the same procedure. It's n times n minus 1, and I go down until I have picked k things, and it turns out when I do that, I pick element n minus k plus 1, and we have notation for that. It looks like this. This is n falling factorial k, or I call this n list k, and the formula for this is just n factorial over n minus k factorial. So that brings us back to talking about the number of k subsets of n. So I'm going to derive the formula for n choose k from the formula for n list k. And I'm going to think of a different procedure, a different recipe that is going to give me a k list. I'm going to pick a subset of size k, n choose k, and then multiplication. I'm going to order it, k factorial. And so that should be equal to n list k. If I move that k factorial to the other side, I actually get a formula for n choose k. And that formula is the familiar one, n factorial over k factorial n minus k factorial. Here's a clean version of this slide with all these formulas. Okay, our last basic counting tool is the binomial theorem. What we're doing is we're taking the monomial x plus y and we're raising it to the nth power. And if we expand that out, we get this expression to the right. And the interesting thing here is that we see n choose k appearing as the coefficients for the x to the k, y to the n minus k term. I claim that when we're determining the coefficient for x to the k, y to the n minus k, we're actually choosing a k set from the set of size n. And here's why. When I expand out x plus y to the n, I have n different copies of x plus y. And when I do the multiplication, I have to pick either an x or a y from here, and then an x or a y from here, and so on. And I have to do every possible combination of choices out of that. At the end of that process, if I end up with an x to the k, y to the n minus k, that means I must have chosen x exactly k times, which means that I chose y exactly n minus k times. And so the number of ways that I can do this, that I get this monomial, I get this n choose k times. And so that's why you see n choose k appearing as the coefficient of these expanded polynomial here. That's our big review of the basics of counting. And just to remind you, we talked about the addition principle and the product principle. And really the takeaway there is that when we're following a recipe to create some mathematical object, and we see the word or, that's going to correspond to addition. And if during this recipe we encounter the words and then, that is going to be a multiplication. The second thing we talked about were our 4 fast friends. These are the number of ways to make subsets and lists. 2 to the n choose k, n factorial, n following factorial k. These numbers are going to appear again and again in the various formulas we look at. And then finally, the binomial theorem is a really, really useful tool. Not only do we use a combinatorial argument to come up with the coefficients there on the right-hand side, but we can also use this polynomial as a counting tool. By plugging in values for x and y, we end up getting some combinatorial identities that we then try to interpret in terms of sets. And that's it for this quick review of the basics of counting. I will see you in the next video.